Hi everyone, today let's solve a Leetcode question called spiral matrix. So given n by n matrix, we want to turn all elements in matrix spiral order. If you see spiral in daily life, you like, okay, spirals look like this. The spiral will start it here, then you will go clockwise, and you will gradually shrink the boundary until you find the most mid element, right? So the intuition is the same for this matrix spiral problem, where you study at this left corner, and then you will gradually visit all elements in clockwise direction, right? Right, so you visit all these elements, and then you shrink the boundary towards middle until you find the most mid element. Okay, I think the intuition is quite simple for this problem. Now let's dive into the coding part, which I will explain one by one. Okay. First, let's write the general framework. So again, we need a result array to restore our element, right? So we'll initialize result empty array. Then we need the top row, and we need the bottom. Okay, so we need the bottom boundary, right? So bottom boundary initialize length matrix, and we also need the left boundary initialize 0, right boundary initialize length matrix 0. Okay. Now efficient initialization. We want to think, okay, while the left boundary is smaller than right boundary and the top boundary and smaller than the bottom boundary. This means there's still some elements inside our boundary and it's still meaningful to search inside the boundary, right? Okay, if that's the case, the first thing to consider is the top row. So let me explain here. First, we want to check the top row. For example, here we have 1, 2, 3, right? And then we check the right column. So for example, here we have 3, 6, 9, right? And then we'll check the bottom row. So bottom row will be 9, 8, 7 in this example. And we'll able to check the left row. So left row will be 7 and 4 in this example. Okay, now finish the coding comments. Let's write the code itself. So for the top row, we want to traverse all columns, right? So all columns in range from left boundary to the right boundary. And we want to append the search result. So just here, we want the top row and the passing column. And after that, we want to shrink the top row downward. So top will be added by 1. Okay, now let's check the right column. So for all rows, all the way from top to bottom, we want to append the element result. So just pass in here, it's a row, and using the right column, right? And after that, we'll shrink the right column leftwards, so just deductly right by 1. Okay. Now the next thing is to check the bottom row. So all the way from right -1, left -1, and this -1 because we are checking the reverse direction. And we also want to append the cell. So just pass it here, and passing column, and passing here. Okay. And we also want to shrink the bottom column, right? So the bottom column will be deducted by 1. And after that, let's check the left column. Sorry, here's typo. For range from I think bottom -1, top -1, and -1. One append it to result array, so change it here to matrix. And you know this one is right, and this one is the left. And we want to shrink the left boundary, so left will be a +y1. But here's two problems here, since in Python indexation, we want to reach the last element. Here we have to use right -1, and here we have to use bottom -1. And finally, we return the result. Okay, the solution looks nice, but there's still a problem here, and let me explain why. Okay, for example, if we run this entire algorithm and in this example too, a mistake will happen. So I'll use drawing here to show you why the mistake will happen. You see initially for this red part, we have the boundary like here, right? So top will be at here, the bottom will be at here, the left will be here, and the right will be here. But after one iteration, we'll shrink the boundary, right? So we'll shrink the boundary towards the middle. And again, we have this yellow boundary. We have top here, we have bottom here, we have left here, and right here. But you see, at this step, left is smaller than right, and top is smaller than bottom. This means we can run the next iteration, right? So run the top row, and we shrink the top row down, and see the top row here is changed to this bottom position. Okay, top row here, and then we want to run the right column, right? And after that, the right column is changed to here, this mid position. But here's the problem if we run this iteration, I mean this bottom row, because we're traversing from right to left, but previously we had traversing left to right and guess this 6, 7 that right. If here we are traversing back from right to left, we are again traversing from 7 to 6, so we'll add additional 6 element here. So it's here, we're actually traversing back in the wrong direction, and we will get the wrong result. So to solve this issue, here's one trick here. Let me clean it out here. We have to add a double check inside this statement. If this condition does not hold in the middle, we want to immediately break this while loop to avoid the traversing back the problem. For example, as I mentioned before, maybe we are traversing previously from 6 to 7, and if we don't add this statement here, it will traversing back from 7 to 6, and the result will be wrong. Okay, now finish the coding part. Let's submit to see it works. Okay, you see the time capacity memory usage of this solution is not bad, right? And although the coding part is long, I think it's very easy to understand, and as explanation is intuitive. Okay, I hope you will find this video helpful. If you like this video, please subscribe to the channel, and I'll see you next time. Thank you.